Heya! Welcome to the newest update for Sonic Entropy, and more specifically, our Cyclone level editor. I'm Blitzy, and I'll be your guide through the changes that we've made since you last saw us. Today, we're going to be talking about the monumental task of moving from DirectX 11 to DirectX 12, and what all that entails to do so. We'll be talking about the differences between the two versions, the challenges we'll need to overcome, the benefits of making the move, what this means for you, and most importantly, the computer you intend to run this on. Before we get into the specifics, what actually is DirectX? Well, DirectX is a graphics API. It's what helps us communicate with your GPU and allows us to focus on building software without caring about the differences between NVIDIA, AMD, and Intel. As long as your GPU supports the version of DirectX that we're using, our software is basically guaranteed to work on your system. The only issue is that DirectX is only supported natively on Windows and Xbox, but there are workarounds like Proton to help us bridge this gap for Linux users. So, what's the difference between DirectX 11 and DirectX 12? Well, excluding stuff like ray tracing, 12 doesn't come with any new features whatsoever, but it fundamentally changes how you would write code compared to 11. Let's compare your computer to an office building. You've got workers on the ground floor, executives at the top, and different levels of management in between. Each floor receives instructions from the one above and passes increasingly detailed instructions to the floor below until the workers finally carry out that work. If you convince the executives at the top to fulfill an order for you, all of the middle managers will make sure that everything runs smoothly, taking care of the complex details along the way. But each manager has to wait for their boss on the floor above to give them an okay before they can carry out any work. However, if you ask the workers directly to fulfill an order, they can start working on it almost instantly. Keep in mind though that you need to give them the exact blueprints or something could go wrong. The higher the level the orders come from, the simpler they can be, but it takes longer to get results. So, how does this affect our engine? Well, DirectX 12 is much lower level than 11, which means the way we communicate with the GPU is a lot closer to what the hardware is actually doing. By being closer to the hardware, we can write much faster and more efficient code because we have direct control over everything that's going on. But there's a catch. DX11 used to hold our hand and automate a lot of the behind-the-scenes work, and now in 12, we have to do a lot of that work manually. Let's go over some of that now. First up is memory synchronization. Whenever you want to modify some data sitting in the GPU, you need to make sure that it isn't currently in use or you could cause some major glitches. In DX11, this was all handled for you. If the data you want to modify is currently being used, the DirectX runtime will create a second copy for you and automatically swap over your changes when the GPU is ready. But with DX12, we have to do all of that manually. We need to check if the data is in use, manually create a new copy, and then wait until the GPU is done before swapping the data over. While it looks like we have to do more work in DirectX 12, this can actually be a lot faster. Because we're now in control of memory synchronization, we can do some of the work ahead of time while the GPU is doing something else. The next big change is pipeline states. A graphics pipeline is basically all the steps a GPU needs to take to go from a pile of zeros and ones to shaded pixels on a screen. It's composed of a variety of different components, and we can swap out individual components for customization. In DX11, you can prepare individual components ahead of time and then swap in the parts you want when drawing different types of objects on a screen. But with 12, we can't just swap out a single stage of the pipeline. We have to swap out the entire thing, even if we only wanted to change one part. So now we have to prepare every possible combination of the stages we need ahead of time and store them as pipeline state objects. It's a lot more upfront work, but this extra work pays off. Whenever you changed any part of the pipeline in DirectX 11, it was secretly rebuilding the entire thing anyway, wasting CPU cycles. By setting everything up ahead of time in DX12, we can now switch pipeline states almost instantly. Additionally, there's switching from immediate mode to command lists. Whenever you tell a GPU to do something, it doesn't do it instantly. Instead, a command is added to a queue for the GPU to process when it's ready. In DX11, these commands get added to the queue immediately, but this prevents us from issuing commands in multiple places, which locks it to just using one CPU core. DX12 gets rid of this immediate mode and instead gives us something called command lists. Command lists are mini queues which don't send anything to the GPU by themselves. This means we can build command lists on multiple CPU cores at the same time. Then, when everything is ready, we dump the command lists into the actual GPU queue. This is a huge improvement for Cyclone because we're now able to issue commands for each viewport in parallel. Finally, descriptors. All the textures used to draw objects live somewhere in GPU memory, but we need to tell the GPU which specific textures we want to use to shade each object. This is done using shader slots, and we can change which textures the shader uses for each object by binding different textures to the slots between draw calls. In DirectX 11, this was pretty straightforward. You will bind the textures, draw an object, and then move on. However, in DX12, we once again have some setup ahead of us before we can start. First, we need to create a list called a descriptor heap, which stores the memory addresses of every single texture. Next, we'll need to create descriptor tables, which describe the number of slots each shader will be using. Finally, when we want to actually bind textures, we tell the GPU where to look in the descriptor heap for each slot. It's important to note that the extra steps that we do ahead of time for DX12 is worth the trouble when compared to DX11 building everything from scratch in the background for every single texture change. Are you noticing a pattern here? DX11 handled a lot of stuff for us, but it would waste time rebuilding things in the background anytime something changed. In DX12, we have to do so much extra setup for everything, but it pays off because we've already prepared the GPU for everything we wanted to do, which makes switching between them almost instant. But writing DX12 is difficult. We've only scratched the surface in this video for all the extra stuff we need to take care of, and it really is a monumental amount of work to even do the basics. So why are we switching Cyclone to DirectX 12? It wasn't because of the performance, because we were getting by perfectly fine with 11, so what's the real reason? To learn. Our plan has always been to build the Entropy engine with DirectX 12, but Pagan had no experience with it. By switching Cyclone to DirectX 12, we'll be able to figure out all the quirks and learn from our mistakes before we have to build an immensely complex game engine with it. Cyclone will absolutely benefit from DirectX 12, but the real benefit here will be the head start that it gives us to reach our end goal. It's kind of like running. When it comes to completing a marathon, preparation is king. It takes months of adhering to a strict plan with no room for excuses, an unshakable motivation to see it through to the end, the mental resilience to endure the hardest days or the harshest setbacks, and most importantly, having the strength of your own convictions to not take any shortcuts no matter how tempting they might seem. And only after the plan has been meticulously crafted and followed to the letter can you celebrate on that winner's podium with your peers.